Today, I will show you how to easily solve each of the 5 different problems shown here using the box rule. With this rule, we can solve a wide range of integration problems with ease and efficiency. The box rule states that if you have an integral of the form where the box is raised to the power of n and multiplied by its derivative, then we can simply increase the exponent of the box by 1 to obtain n plus 1 and divide the result by n plus 1 to calculate the integral. Here's our first example. Now, let's bring in the box rule. If you take a look at the problem, it has the same form as our box rule. Therefore, the exponent of the green box is 4, and we can put like x cubed minus 4x squared plus 7x inside the box, and 3x squared minus 8x plus 7 in the box prime located behind. Now, we are all set. Let's put in the box on the right to find the answer. The exponent of the green box on the right will increase by 1 from 4, and the denominator will be 4 plus 1. Finally, we just need to put the same terms, x cubed minus 4x squared plus 7x, inside the green box. In the end, the answer will be x cubed minus 4x squared plus 7x to the power 5 over 5 and plus c. Now let's take a look at a slightly different case. If you look at the terms inside the second box, which is the box prime, they are not the differentiated form of the terms inside the first box. What should we do in this case? Let's take a look at together. First, let's bring in our box rule. Let's set the exponent of the first box to 3, just like in the problem, and fill the box with the 4x squared minus 2x plus 1. However, we encounter a problem with the second box prime. We can't simply put in 4x minus 1 as it is. We need to differentiate the term of the box, which is 8x minus 2. Let's do simple math here. The 8x minus 2 that we need is actually 2 times 4x minus 1. That means we just need to multiply by 2, but we can't just do that freely in this problem. So we will multiply by 2 over 2, which is equal to 1. Then we move the denominator 2 to the front and multiply the numerator 2 to 4x minus 1 to create 8x minus 2. Let's bring up the box rule again. Now we are ready. Multiply half in front, fill the green box with the 4x squared minus 2x plus 1, and the second box prime will be 8x minus 2. Of course, the exponent of the green box is 3. The answer on the right is the same. Multiply half in front, increase the exponent of the green box by 1 to 3 plus 1, and the denominator will also be 3 plus 1. Fill the green box with the same terms. Then the answer will be half multiplied by 4x squared minus 2x plus 1 to the power 4 over 4 plus c. To simplify, it can be expressed as 4x squared minus 2x plus 1 to the power 4 over 8 plus c. Let's try integrating a fraction this time. First, let's bring in the box rule. And if we express the problem with a negative exponent, it becomes 5x minus 1 to the power of negative half. We need a 5 in the box prime, but we don't see it. What should we do then? Once again, we multiply by 5 over 5. As a result, multiplying by 1 has no effect on the formula. We move the denominators 5 to the front of the integral and leave the numerators 5 behind the box. Now the box rule comes into play again. We are ready now. We put 5x minus 1 in the green box with the exponent of negative half, and we put 5 in the box prime. We also multiply by 1 over 5 on the right, and the exponent of the green box and the denominator both increase by 1. Now we fill in the box with the 5x minus 1, and the answer is complete. The answer is 1 over 5 times 5x minus 1 to the power of half divided by half. So we multiply both the numerator and denominator by 2 to get rid of the denominator's half. Then the half in the denominator disappears, and the answer becomes 2 over 5 times 5x minus 1 to the power of half plus c. This problem may seem more complicated, but we can easily find the answer using the box rule. Let's express the denominator as a negative index and then apply our box rule. The first green box will obviously be negative 2x squared plus x plus 3 with an exponent of negative half. For the box prime on the right, we simply bring down negative 4x plus 1. The power of the green box in the final answer will be negative half plus 1, and the denominator will have the same value. Now, all we have to do is fill in the green box with negative 2x squared plus x plus 3, and we are done. So the answer is negative 2x squared plus x plus 3 to the power of half divided by half, and plus c. As you can see, to eliminate the half in the denominator, we'll multiply both the numerator and denominator by 2. Therefore, the final answer is 2 times negative 2x squared plus x plus 3 to the power of half and plus c. Now let's try solving one more problem. Take a look at our final example. We'll try to solve the integration of trigonometric function. Can you see who the box is and who the box prime is now? The term sin x will go in the box, and you can see that the box prime is cosine x, right? Just like before, we'll increase the exponent of the green box on the right by 1, add 5 plus 1 to the denominator, and fill in the box with the sin x to finish our work. So the final answer is sin x to the power of 6 over 6 and plus c. Today we learned how useful the box rule can be by solving 5 different examples. We learned the most basic box rule, which eliminates the need for integration by substitution. In the next lesson, we'll explore more diverse cases of the box rule. Thanks for watching. I will continue to prepare and upload the videos that will help you learning. Please subscribe and like, and have a great day. This is Alex, signing off.